Hello everyone, welcome back to the second video from the series Intro to Aerodynamics by MotoManipal. By the way, this is Syed, Aerodynamics Head at MotoManipal. A quick recap. In the past video, we have learned the basic concepts of aerodynamics, the cooling process of aerodynamics, etc. It was beautifully explained by my colleague Rishabh Suri, so I recommend you all to go and check that. So as promised, in this video we'll be learning basics of CATIA generative shape design. We'll be designing a fairing on a given chassis and later simulate that on ANSYS Fluent. Hope you'll all learn in this video. So without wasting any time, let's get started. I'm using CATIA V5 R19 version of the software. We'll be learning generative shape design workbench. So in this workbench, we mainly deal with thin negligible sheets which can be molded around as per your requirement. Unlike in part design, we used to deal with thick and defined solid objects whose thickness we used to define. In generative shape design, after drawing a required shape, we add thickness according to our requirement. Say it 1 mm, 2 mm, 3 mm, whatever it be. So let's start learning generative shape design. So first go to start, shape, and then generative shape design. At the bottom right, you'll find the name change. So I'll give the name GSD1 and click OK. So this is the screen. We'll be learning the tools multi-section, fill, extrude, split, and the plane in the basics section. And the other we'll be learning in the upcoming section. So to draw, first I'll select a plane, click on sketch and see. So we'll get a sketching workbench here. So first I'll select a circle, draw a circle, and then give its diameter as 150 mm. Exit the workbench. So now I want to draw another circle right hand side of this given circle. So let's draw. So first I'll take a plane, offset it out of the present plane with 50 mm distance. So I'll click on that plane and click sketch. So instead of drawing the whole circle again, I'll use a command project 3D elements. So when I click on the present sketch, that will project a similar sketch on this plane. So as you can see, both the dimensions are also similar. Exit the workbench. So the first tool which we'll be going to use is the multi-section surface tool. For this, I choose one sketch and the other sketch and preview. See, you can see a surface has been created between two sketches, and you can also see the thickness is very negligible. Great. Now the next tool which we'll be using is the fill tool. So this tool mainly is used to fill up a close contours. For example, here the circle is a close contour, so I select that, click OK and see. Even on the other side, I'll perform the same operation. Fill, select the close contour which is the circle, click preview. It is closed, correct? So OK. See, now you can see we have a thin cylinder. Just I think that for your awareness, the cylinder is completely hollow. That means there is nothing filled inside. And yeah, let's uh, draw another sketch on one side of the circle. I'll consider to be a line first. See, I draw a line. The blue one indicates that it is a straight line. So exit the workbench. Now I'll be doing the operation extrude here. I'm sorry. The extrude, yeah. So this tool extrudes or creates a surface along that line. So I'll give the required dimensions for the extruded part. So say it 500. So now I'll use the split. Basically what the split does is it splits the selected object and the other object. So for example, I've selected the multi-section and the extruded surface, and see, it removes that part. If you click on other side, the other side will be removed. I'll click OK. Now you can see the other side has been removed completely. Yes, I have selected the multi-surface part, so only that part has been removed. So I'll perform this operation again on the fill parts. No, this is not the side I want to. I'll click on the other side. See, I'll click OK. And the other one. Repeating this thing again. Done. Now I'll hide the extruded surface and see, this is the resulting surface which I have got using these few simple tools. We'll be using mostly the same tools in making the fairing as well. So these are one of the most important tools in generative shape design. Now let's start with the fairing. So to start, first click on start mechanical design, and I'll start with assembly design and create a product first, because I want my given chassis and the fairing to be two completely different parts instead of merging them in one. So first I need to bring my chassis here. So I've already opened my chassis in this. So I'll right click there, copy, and paste this part in the product which I've just opened now. So this is my chassis. So now it's time to bring out another part on which I'm going to make the fairing. So the same, double click on it to activate that part. See, the important thing is to find the symmetric point or symmetric line over the chassis, so that you can reduce your work by building the fairing on one side and using the symmetry and transferring over the other side. So that point seems to be symmetric. So I'll bring out all the planes and make it over there, or bring it over there, so that I can use that planes as the symmetric planes, and if necessary this can be offsetted to the other parts as well. So I'll offset all the planes at that point, and I'll to select the view. This is the better view to start the drawing with. Now it's time to offset the plane, or first let's draw the outline of the head which I want to make, because drawing the head sketch first generally helps you out, because that seems to be the most complicated part, and that gives you a base outline how to go about the other sketch. So I want this to be my shape. Exit the sketch. So now I'll offset that plane to that point so that I can draw the head, the topmost part of the fairing, which is the topmost edge of the windshield. So first, for symmetric, I'll choose an axis and bring it to the axis point of the chassis. Remember, this is one of the most frequently steps which we are going to use in further. So first, I'll shape my windshield outline. So make sure this point coincides with the point of our rough sketch of the head, so that we have a reference line. Yeah, now symmetry. This seems to be proper, so let's exit the sketch. Again, I'll offset a plane over that point, start sketching again. This will be the shape of the main fairing. Again, as I said, we'll be repeating this step, deciding the axis. Coincide, yes, okay. Now using the spline, I'll be giving the shape for this. And also again, make sure both things coincide, both points coincide. Make sure it's not too wide, because too wide fairing is also not a good looking fairing. Symmetric again to transfer that to the other side of the axis, making the front part a little curved than a sharp corner. See, for a better control, I'll draw multiple sketches like this to have control over the fairing. So again, I've offset on that point. As I've already explained in the basics, you just need to select that previous sketch and use 3D project 3D tool so that it projects the same sketch on that plane as well. So as you can see, so now it's time to decide the bottommost point of your fairing. It's an iterative process, so I'll just try to see with 700. No, try it with 600. Little too less. I guess no more. To 550. And this is supposed to be fine. Click on that sketch. Yeah. So in general, the fairing will be converging towards the end. So try to make the bottom part as thin as possible, so the whole thing seems to be converged. Repeating the same thing again, chassis axis, and drawing a sketch using the symmetry. Note, we are mostly using these simple tools and simple methods to make this fairing. Be careful that the front part of the sketch does not intersect with the front tire. Now let's start multi-section. Yeah, one thing I forgot. These two are joined, so to separate them, I click on extract so that two lines are separated and which can be used as a guidelines for multi-surfacing the other two sketches. Yeah, extract, done. So now multi-surface tool, I'll select two sketches and then click the guideline. Make sure those two arrows are on the same. Yeah, there's a mistake that we did not, I think we did not touch those 2 points. Yes, it seems to be fine now. Let's try once more. Multi-surface 1, 2, guideline, this one, okay, seems to be fine. Again, multi-surface, this sketch, and this as the guideline. Review. Yeah, it's fine. Okay. So now it's time for the bottom one now. This and this here. Review. Yes. So here's our fairing ready. No, just kidding. We'll be modifying it again so that it looks much better. I mean, I'll join these 3 things first because when I split them, I need not use the operation split on each and every multi-section I did. So to draw the splitting line, first I'll go to that plane, sketch, and the front part first, the space for the radiator. Make sure it comes out a little bit more. And for the top part, I just wanted to say this fairing design might not be pleasing to few people or might not be as good looking as other people can make. So I just wanted to say this is only for the learning purpose. I'm not trying to showcase any of my skills. I just try to explain you in a simple words because this is the simplest way you can make a fairing. There are many complex methods as well. I hope you learn with this. So yeah, exit the sketch, extrude these things. I'll give some random number so that it projects out. 500 see. So now I'll use the split tool and split them out. This and select the extruded part. Okay, this some error. I'll try again. Selected. Yeah, now it's fine. Preview. Okay, so this is our final fairing. I'll hide all the unnecessary surfaces and sketches. The top part seems to be too long, so I decide to even cut that part. Sketch. Yeah, split again. Yes, okay. Preview. Oh, fine. And hide that again. It seems to be a pretty good and decent chassis. If you want, you can make a hole in front as well for the headlights. I think let's do that. I'll be choosing a rectangular shape. You can also give the eye shape thingies as well. Yeah, now it's time for the same extrude. Okay, and go with splitting again. You guys have noticed I've just only used few tools, which is very simple and easy. Let's cover the bottom part as well. First I'll add all this sketch which interface. Okay, yeah, preview. There might be some error. Okay, I'll look after that after hiding all these sketches. I'll just add the required amount of thickness, that could be 1 mm, 2 mm or 3 mm, which could be sufficient. And remember, do add thickness before importing it to the Fluent. So this is ANSYS. Generally we use ANSYS to study a particular object or phenomena under certain conditions. In this we use the external flow. So for that we need to use Fluent, so which is on the left side. So I'll click that, drag it down on my project area. So I'll right click on geometry and import my geometry. I'll right click again. I'll choose design modeler. There's also a geometrical software inbuilt called SpaceClaim, but I'll be using design modeler, which is very simple compared to SpaceClaim. Yes, 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 and generate. So this is our fairing on design modeler. So first I need to make an enclosure around this. So to make a flow domain over it. So first I'll bring the plane near to the fairing so that I can make the enclosure properly. So I'll select plane from point and edge. I'll select that point, apply, and the base edge to be the edge above that. I have to click it carefully. Yeah, selected, done, and have to generate it. Yeah, sorry, yeah, generate. Now as this plane has been generated, I'll go to sketch and model our flow domain. Generally there's an inbuilt tool for flow domain called an enclosure. I can use that as well, but that won't be easy to work around with the dimension as well. So I prefer to make a sketch and do it by myself. I think 300, yeah. In this way we'll have much more control over the flow domain dimensions. Now I'll click that extruded, yeah, 3000 mm. I'll extrude it on one side, generate, yeah, as you can see. So now it's time to create boolean. In this way I can subtract the fairing from the flow domain. Yes, done. Target body, yes. Make sure you click no for the preserve tool body, and here it is. I've only used half of this fairing because the other half is symmetrical, so will be the same at the other side as well. So this saves my computation time and resource. Now it's time for, now first I'll update this. Updated. I'll close this. Now I'll go to mesh. Edit. So this is the meshing window. The mesh. Click generate. Just to see the outline of the general mesh, how it creates. And here it is. As you can see, those denser parts are fairing. We need to make much more denser mesh over the fairing surface. So I'll give a sizing. No. Element size, yes. First I need to select my fairing. So better idea is first I'll select all the faces and then subtract the outer domain faces, which will give me the faces of the whole fairing. Click, yeah. As you can see, the fairing has been highlighted in the green color. See, apply and reduce the element size. And generate, yeah. And now you can see there are dense meshes. There is a dense mesh near this face. Mesh. To check the quality, first click on aspect ratio. It should be minimum as possible. Yeah, the blue color indicates it is minimum. Next, the skewness factor, and this should be minimum as possible. So it must be blue, but right now it's fine for our further simulation. In general, it should be mostly blue in color. Next, for orthogonal quality, the same, yes. Now it's time for Fluent. Right click on. First, I'll check the mesh quality, not the units. Check. Then report quality. Seems to be fine. It is a pressure based simulation and a steady state one. So I'll select the turbulence model, which is K omega SST. I'll change, that was my default, so I'll change to K epsilon realizable scalable work function. So this turbulence model help us in resolving the turbulent flows. So in the materials, density constant, yeah. Boundary conditions. I forgot to mention, I had named all the faces of the flow domain to be inlet, outlet, surroundings and symmetry. I'll give the inlet condition 27 mm and the outlet to be pressure outlet. Fairing is wall. Surroundings the wall, yes. Symmetric, the symmetric side. I'll check the reference values. Select the inlet. It is 27, fine. Velocity is 27 meter per second. Method coupled, yeah, good. Make sure everything is on second order upwind. That gives you that helps you giving it an exact or an accurate solution. Okay, I'll click on monitor and residue. I'll change it to 10 power minus 5. This is the convergence criteria because it stops the simulation after this number of, when the solution reaches to this state of convergence. I'll copy and paste them. Okay, and initialize. And the next is calculate. Number of iterations, I'll give it to be 1000. Yeah, not 10,000. Calculate. Now it starts calculating. CFD is a topic which helps you understand each and every term in the software in depth perfectly, because Fluent uses CFD, computational fluid dynamics parts, to solve inside it. That means in the front you will be able to see all this nice data and pictures, but behind, inside the CPU or inside, the software uses all the rules and regulations and activities from computational fluid dynamics to solve each and every problem with respect to each and every flow, each and every vortex, each and every curls it has. The turbulence model helps us in selecting the particular method of calculation you want to use. So in this data you can see 10 e power minus 4, 10 e power e minus 5, e minus 5. This shows till which convergence this particular term has reached. Say y velocity, it has reached up to 5.155, e minus 5 convergence. See, this is the graph. They seem to fall down because they have to reach till 10 power minus 5, which I given 10 power minus 5. Sorry. This is the post-processing section of ANSYS. So I'll first select contours. Yes, all domain. Fairing. Contours to be 100. Display. So now you can see the red, white and the colorful things. Those represent the gradient of, for say pressure I've selected here. Pressure gradient, how high it is or how low it is, and where it is high, where it is low. The scale is given beside, red being the highest value. As you can see, the pressure is high at the front nose compared to the back side. So yeah, thank you very much everyone. That's it from my side. Hope you all learned something from this video and the previous one as well. So if you guys have any queries, any doubts, you can feel free and contact us. Me, Syed Musharraf and Rishabh Suri, the team leader as well. So thank you very much.